Have you ever wondered how different computing devices talk to each other, regardless of the vendor who make the hardware or software? How is it possible to access a website hosted in Linux server from a web browser? In this video, let us understand basics of Open System Interconnection or OSI model and high-level steps involved in communicating with another device over the network. OSI model helps to understand network communication better by dividing the whole process into 7 different layers. Each layer performs unique functions. First layer is physical layer, then data link, network, transport, session, presentation, and finally 7th layer is the application layer. What is the purpose of application layer? This layer consists of protocols and standards that help an application to talk to another application over the network. For example, HTTP or HTTPS is used to talk to web applications. SMTP is used for email communication. FTP or SFTP is used for file transfer. SNMP, Telnet, so on and so forth. Presentation layer. As the name suggests, function of this layer is to convert the data from application layer to a presentable format so that it can be understood when it reaches the remote device. Information about compression will be added in this layer. Compression will reduce the size of data. Sender should let the receiver know the data format. For example, if the file type is PDF, then the receiver should know it. This information may be added in this layer. Encryption information also may be added in this layer. Session layer is responsible for managing sessions. It is responsible for creating, maintaining, and terminating sessions between two devices. Any protocols or standards that help to achieve this function will be part of this layer, like L2TP, RPC, NetBIOS, SOCKS. All of these comes in this layer. This layer is also responsible for authentication and authorization function. The transport layer is responsible for transporting data from one device to another. Commonly used protocols are TCP and UDP. TCP is used when you need reliability. UDP is unreliable. Then why UDP? What could be the reason for using an unreliable connection? Speed. UDP is faster than TCP. The only problem is that there is no way to guarantee that the data reached the other device. However, this is suitable for traffic like video streaming, where it is fine to miss some traffic. Source and destination port details also get added in this layer. What is the purpose of port? You may have several applications running on your laptop, like a web browser or email client. The server may also have several services running on it, like web service and email service. How will the web traffic initiated from the laptop browser reach the web service on the server and not email service? A web service will usually run on well-known ports like 80 for HTTP. Email service will usually run on port 25 for SMTP. The browser application in the laptop will open a random port, say 57423, and this will be the source port. The destination port may be port 80 as it is web traffic. So the information will be transmitted between port 80 on the server and port 57423 on the laptop. There may be another port in the laptop talking to port 25 on the same server for email traffic. Network layer is responsible for routing traffic between different networks. Devices like routers, layer 3 switches, and protocols like ICMP, IPsec, OSPF comes in this layer. Assume that a laptop is connected to a switch and server is connected to another switch in a different network. Both networks are connected using a router. How will the traffic from laptop reach the server in another network? The router will need source and destination IP address to route the traffic. This information is captured in network layer. Data link layer is responsible for sending data across the physical media to the destination machine in a network segment. Devices like layer 2 switches and protocols like Ethernet, HDLC comes in this layer. Let us say that laptop A is connected to the same local area network as laptop B and they are connected to the same switch. Switch will need to know source and destination MAC address to direct the traffic. This information gets added in data link layer. Physical layer is responsible for actually transmitting data through a media as electric signals. The media can be cable, optical fiber, wireless, so on and so forth. Devices like network interface card comes in this layer. As we now have a very high level understanding of OSI model, let us look at steps involved when you try to access a remote website from your laptop. First, you may open the web browser in your laptop and type the website address. HTTP or HTTPS may be the protocols used in application layer. This information gets added here. Information about data formatting, encryption and compression will be added in presentation layer. Data format may be HTML as we are discussing about web traffic. Information about authentication and session management may be added in session layer. Transport protocol information TCP in this example will be added in this layer. Source port and destination port may also be added in transport layer. This is now called a segment. Source and destination IP address gets added in network layer. This is now called a packet. Source and destination MAC address gets added in the data link layer. This is called a frame. Now the data will be transmitted to destination server using any media like copper cable or fiber optics or wireless. The process of adding information in each layer is called encapsulation. The reverse process of de-encapsulation happens when it reaches the destination server. Physical layer will send the frame to the data link layer where the destination machine gets the source and destination MAC address. Packet will be sent to network layer, segment will be sent to transport layer, so on and so forth. Each layer can get information associated with them and process it. Finally, the web server gets the request to view the web page. Understanding OSI model is important to see how devices communicate over network or internet. It may also help in troubleshooting complex network issues.